Hi, welcome to Chapter 2 of the Line of Business Development course on Universal Windows platform-based applications. This chapter covering solution architecture and best practices. My name is David Kelly. I'm the CTO for Zensa and a Microsoft MVP. So first, if you go through the sample material, we have a sample that is focused on login and MVVM. I encourage you to go through the sample, but it shows some key aspects of MVVM. It's basically a login form. You get to fill in some data and see how the MVVM works. So let's talk about that MVVM architecture. So MVVM consists of a view. So this is what you see on the screen. It's designed in XAML and allows us to define all of the elements or all the classes. It's more or less an object tree that represents what you see on the screen, and then we can programmatically manipulate it. There's also a model. So a model represents the data. This is classes or objects that have been deserialized coming back from the database that we're able to manipulate. And then we have this thing called a view model that sits in between. It basically binds the data and presents it in a way that can be bound to the view using a declarative model. It contains state and data for the view. So the view model gets that data, and then the binding injects it into the view. And then also frequently manipulates the view in various ways, depending on that data, whether it's a property that will hide a control or it will give it a special default setting or something akin to that. Now, frequently, there's also another design pattern called commanding or commands that's associated with MVVM. But it is important to understand that that's a separate model. Commands is an easy way for you to create classes that control behavior that might change out view models. They might change views based on, if you click a button, maybe it's looking at form values, and then it'll push you onto another view if certain criteria has been met. So why MVVM? MVVM allows you to have separation of concerns. It's a really good way to separate out what you see on the screen and the business logic. It allows a designer to come in and play with the view without affecting what the developer is working on in the view model. It allows for testability because you can wire harnesses on top of that business logic without affecting the view or dealing with the view. And that also allows you to develop multiple views that can be snapped on top of the same set of view models. And it also, from an engineering standpoint, allows you a shorter time to market. And what that means is that I'm able to build an app more quickly using MVVM than if I were to hand code a really complex business application from scratch. And from a business standpoint, that it gives me an edge in terms of delivering that functionality to my end users or my target demographic. So one of the things that people, as an engineer, if you've been in the field for a long time, or not just engineers, technologists in general, you'll know what it means to have slow access, or your computer's going slow, or maybe you have too many processes running and it's causing some performance issues. And some of you may recall screens like this. Now, this happened when the thread in front was taking up too many CPU cycles, and the screens or the other UI threads in the background weren't getting enough cycles to repaint or redraw their screen. So if you would pick up a window and drag it around, you would get things that look like this. Now, the reason that happened is because those programs weren't multi-threaded, essentially. So they're not designed to work in an asynchronous way, but a synchronous model. Now, typically, coding asynchronously is difficult. There was a lot of threading code, a lot of stuff you had to produce to be able to get a software program to behave that way. But wait, async to the rescue. So this is a new keyword or sets of keywords and structures that you can use inside your applications with the current or new version of C# and UWP that allows you to program asynchronously without a huge shift in thinking and structures in terms of creating threads and thread management to be able to program asynchronously. So if you go through the code that we've provided, you can see how you might use async and the keywords that you can use with async, so await and async together, to be able to program asynchronously in a way that looks more or less like synchronous coding, so it's more what you're used to. Another thing we need to talk about is application lifecycle. So application lifecycle, when you're talking UWP, is really about when your application is running and when it's not running. In Windows, one of the things you can take advantage of, and you should take advantage of, is the ability to suspend and resume or deal with when Windows is going to terminate your application. Because a lot of times there are cases when you don't have any control. It's just going to be cut off because maybe the user activated another program, there's too many applications in the stack, and it's just going to drop the lowest one. And you have the opportunity, though, to suspend that application. You can use like the onLaunch event or the onActivated event to bin the application up or rehydrate any data and put it back into the state that it was. You can see here's some sample code in terms of on suspending, which is invoked when the application execution is being suspended, and you can go ahead and save some of that application state. Now you got to do it quickly because your program only has a little narrow bit of time that the computer is going to give you before it's suspended, and then you can save that information for the user, and then when you come back into the application, you pull that back up, and you've saved that state, whatever that is, and the user can continue on where they left off. Now remember, with Windows Universal Apps, it's really about being able to have a single uniform code base and get it onto lots of different applications or lots of different form factors. That can be the phone. We have these large phones, sometimes called phablets, or small tablets, large tablets, tablet-laptop combinations, like the flip-over laptops, classic laptops, all-in-one desktops, Surface Hub, Xbox, HoloLens, and even IoT devices, little microcontrollers that run the new Windows 10 IoT. So you can use that same skill set, that same tools, and build those applications for all of those different platforms. Now, some of the challenges to UWP is you need to be able to adapt applications to different screen sizes, or no screen for IoT, as the case may be, or a holographic display for HoloLens. So when you're planning your applications, you've got to take into the account the context in which the application is being used. If you're going to do a business app for HoloLens and you want to do holographic displays, you might need to consider getting into a different set of technologies. UWP applications might be for business applications. Well, let me retract that. For HoloLens, you do UWP, but then the holographic components are going to be done in Unity, whereas for line of business applications, you can do the whole thing in UWP, but you need to plan for that. You know, how is the application going to change from a phone to a tablet to a Surface Hub? And you have like the concept of virtual pixels that you can use to make sure your application looks kind of uniform across all those different screens. Additionally, you need to think about other input methods, whether that's mouse, keyboard, touch, ink, controllers, gestures, and different kinds of things like that. Another thing to consider is viewing distances. There's a big difference between looking at Surface Hub that's across the room and looking at your phone that's right there in your hand. And another thing to think about is CPU or RAM and the computer hardware that it's running on. Again, there's a huge difference between a small IoT device and a phone versus a high-end Surface Pro 4 or other high-end hardware. And so working through all those scenarios are critical to being able to deliver a really good Universal Windows application. So let's watch this video.
The Universal Windows platform provides the building blocks you need to create elegant and adaptive Windows apps that look great on a wide variety of devices. First, UWP automatically adjusts the size of the controls, fonts, and other UI elements so that they are legible on all devices. UWP uses a new effective pixel system to achieve this. UI elements are automatically optimized for perceived size, so that a 15-pixel font on a Surface Hub 10 feet away is just as legible as a 15-pixel font on a smartphone in your hand. With this, you can ignore details like pixel density and screen resolution, and focus on how you want the app to look. Second, UWP's Universal Input System automatically understands a variety of input from different devices. You don't have to worry about how your UI responds to the tap of a finger, a mouse click, or an air tap on a HoloLens. It just works. Third, UWP apps come with a set of universal controls and styles. Universal controls work well on any type of Windows device. They adapt to the different screen sizes and different input modes on each device. Our built-in universal styles come in two themes, light and dark. These styles use a Segoe-based font that looks crisp at all sizes, supports high contrast modes, and supports adapting your app to other languages. You can ship your app with these styles and it will look great. Or you can use these styles as a starting point and add your own personality to the look and feel. You might want to optimize the use of screen space, take advantage of specific sensors, or tailor the experience for a specific type of input. If this is the case, there are some techniques to help you design your app for a specific screen size. We call these techniques the 6 R's. Depending on whether a screen is portrait or landscape, you may want to reposition some content. It may be easier to scroll content vertically on one device and horizontally on another. If you have a larger screen, you may want to resize some elements and adjust margins and spacing. This may improve readability and comfort. There may also be times you want to reflow content by adding another column if the screen size allows it. Also dependent on the size of the screen is whether you reveal or hide some elements. In tighter spaces, you might want to hide controls until needed, whereas on a larger screen, they could always be visible. In some cases, you may want to replace or re-architect some UI. You may want to change how you dive deeper into data and take advantage of the layout of the screen. The Universal Windows Platform takes you a long way in creating apps that run great on all Windows-powered devices.
Okay, with that, you should dive in, check out the 3 samples. We have the one on the camera and the other 2 samples go along with this chapter. I encourage you to walk through them step by step, and you should be ready to go to really start writing some UWP applications.